Hello YouTube and welcome back to another video. In this video, we'll continue with part 2 of Descriptive Statistics. Today, we'll be looking into the measures of dispersion. Before going into it, let me recap what we covered in the previous video. In the last video, we've looked into the measures of central tendency and have very briefly touched upon the measures of dispersion. Measures of dispersion attempt to identify the spread of the data on the number line. In other words, it tries to identify how far each of the individual elements or data points in the dataset are from the central value. Hence, it's also known as the spread. Continuing off of the previous video, we'll be using the two locations and their temperatures as an example. After calculating the mean temperatures for both those locations, I left you all with a question. If you had to set up an ice cream shop based on this data, which location would you select? Given that you have no access to any other information but this, and assuming that higher the temperature, higher the sales of the ice cream, which location would you set up shop? Now, if you're going just by the average or the mean, unfortunately, it provides us with no meaningful information. Since the average temperature of both the locations is 32, this is where the measures of spread or dispersion come in. As I said, measures of dispersion attempts to describe the spread of the data. These include the range, variance, mean standard deviation, quartile deviation, and there are a couple of others which we'll talk about when we get there, but for now, these four are the basics. First, let's take a look at range. Range is the simplest measure of spread. It is calculated as the difference between smallest and largest value of the observation. Range is extremely useful to look for or weed out any outliers. Now in our case, the range would be 40, which is the maximum value in location A, and 20, the minimum value in the same location, and the difference between the two, which would be 20. Now, range is extremely useful, like I said, to weed out any outliers. For example, if a large data that contains ages of people with the minimum being 10 years and having no limit on the maximum age, you get a range value of 120. This would mean that the maximum age in the dataset is 130, indicating that the observation of 120 might be an outlier or an aberration. Let's look at the variance, which is sum of squared distances of each value from the mean. Standard deviation, which we've talked about previously, is the square root of the variance and is an extremely common metric for the spread. About 95% of all the observations in a dataset will be within 2 standard deviations of the mean, also known as the reference interval. This metric is extremely useful when the data is normally distributed. Standard deviation, however, falls short when used for highly skewed data. To counter this, we can use the quartile deviation. Quartile deviation breaks the dataset into quarters, and then we calculate the range for each of the quarter, also known as the interquartile range. Now that we've covered the basic definitions and use cases, let's try to see visually how this works. In this slide, you will notice that I've plotted out the observations on a number line. We know that the mean temperature for both the locations are 32 degrees. The red points indicate the temperatures of location B, and the blue points represent location A. And now, all I've done is just move the graph vertically. The range of location A, or the maximum minus minimum value, is 40 minus 20, which is 20, whereas the range for location B is 50 minus 10, which is 40, giving you a range of 20 degrees and 40 degrees. What this is showing, as you could see, is that the temperatures are more spread out in location B. They tend to be more variable or dispersed compared to location A and by 20 units. Next, let's look at standard deviation and try to see how this works visually. The 32 represents the mean, and now I'm just plotting out all the points. As I'm plotting all the points, the first thing that you'll have to do is calculate the variance. In order to calculate the variance, take each of the data point and calculate its distance from the central data point or the mean. So the first data point that I've used in this example is 30. 30 is 2 units away from the mean. 40 is 8 units away from the mean, and similarly I continue this for the rest of the data sets. And once you calculate those, square the distance of each of these data points and add them up together. So I take -2, 8, 8, -2, and -12 for location A, add them up together. After squaring, that will give me the variance of 280. And the standard deviation is the square root of the mean. Similarly, for location B, I take the distance, square it, and then add these distances together, take the square root of the value or the variance, and that would give me the standard deviation for this data set. I hope this gives you a visual understanding and a very brief overview of what measures of dispersion are. In the next video, we'll take a look at how to use R to calculate these values. So if you found this video useful and the content helpful, then please like, share, and subscribe. If you didn't, there's always the dislike button. Until the next video, stay safe, take care, and peace.